Hey, Science 8, welcome to your first unit on fresh and saltwater systems. We're going to learn so much about water this unit. You're going to love it. But first of all, we're going to talk about just why water is important and a little bit about the water cycle. So this is called a world of water. So let's get into it. To start off, to talk a little bit about why water is important. Water is very important to life. More species of organisms live in water than any other places on Earth. So we look at all these land animals that we have, and that's just part of the living things we have. And in fact, it's the smallest part of the living things we have. Most organisms actually live in the water. And on top of that, all organisms obviously need water to survive. If there is no water, there is no life, which is why when they discovered water on Mars, it was such a big deal because it means that there could be life there. So, a few facts about water and how it supports life. First of all, water covers 70% of the surface of the Earth. So, most of the Earth's surface is actually just water. Most of the water, 97% on Earth, is unfit to drink because it is salt water, so we cannot actually consume it. As you learned about osmosis, right, earlier in the year. If we drink salt water, it actually pulls water out of our cells because it is hypertonic compared to our hypotonic cells. In other words, the water moves from where there's more water inside our cells to where there's less water in the salt water we drank. Of the 3% of the water that is fresh water, 3/4 of that is locked up as ice in glaciers. So that leaves us with 1/4 of 3% that actually is maybe usable. So just over 0.5% of all the water on Earth is available as fresh water for us and other organisms that need fresh water to drink. And 97% of that is found below the ground. There's so little water that's drinkable. Anyway, so that gives you an idea of when people talk about water shortage, you're like, well, there's water everywhere. That's why. Most of it is either not drinkable because it's salt water, it's not accessible because it's tied up as ice in glaciers, or it's under the ground. We depend on fresh water for many reasons. So, for example, 65%, 2/3 of our body mass is water. So we have tons of water, obviously, inside of us. Everything our body does uses up a little bit of water. So the chemical reactions that are happening all the time inside of our body are dependent on water to happen. We desperately need water in order for us to function properly. Every time we breathe, we actually exhale some water in the form of water vapor. You can see this when it's very cold out, right? And you can see your breath. That's because of the fact that our breath contains water. Our lungs and stuff are moist inside, and water is always leaving our body as we even just breathe. Our body also gives off water in the form of sweat in order to keep our bodies at a constant temperature at 37 degrees Celsius. So when we start getting overheated, when we exercise, when it's hot, we sweat. And then actually through the process of evaporation of water leaving our body, we end up cooling down. And the reason why is because when water evaporates, evaporation takes energy in order to happen. So it is absorbing energy from our skin in order to evaporate from our skin. This is called evaporative cooling. This is why when you first step out of the shower, you feel very cold. It's because the water on your skin is evaporating off of you and it is cooling down your skin as a result. It's like you have sweat on you, but it's not sweat, it's water. So water, very important, obviously, to us and to life. We lose water every time we use the bathroom, obviously, both pee and poop, right? We're losing water as a result. And all the water that our bodies use must be replaced in order for us to function properly. So we must consume about 2.5 liters of water each day in order to remain healthy, depending on your size. Could be more, okay, but definitely 2 liters. So I like to think of it as if you have like a large 2-liter bottle of pop, you should be drinking at least that in water, not pop, but in water each and every day in order for your body to remain healthy. Okay. And this is actually one thing that people don't realize. This is often why people are tired, is because they don't have enough water in their bodies. When you don't have enough water in your body, you can't do the chemical reactions that are required for energy, for cellular energy to be made and to get used. So when you feel really tired, instead of reaching for an energy drink, maybe reach for a glass of water, and you might find that it does a lot more for you than other things would. But often, that's the reason why we feel tired or lethargic. In fact, in the morning, that is one of the best times to drink water. You haven't had water for however long you've been asleep. So get up, drink a few glasses of water. It will help you to wake up and get going with your day. We depend on fresh water for things other than our body processes and physical health. We also use fresh water for recreation, for hygiene, things like showers, brushing our teeth, washing our hands, putting out fires takes water. We give it to our pets, like my pets this morning who were out of water and bugged me all night because of it. Silly cats. Water our gardens for drinking, for cooking, for farming. Farming takes a humongous amount of water, huge amounts. And for manufacturing, also a large amount of water goes into manufacturing. Other organisms make their homes in the water as well. And look at that wonderful otter just doing its thing. Waters are amazing. In fact, at the Calgary Zoo, I think that's my favorite part. There's two things I love at the Calgary Zoo. There's the red pandas and there's the otters, and they are just so charming. Anyways, water is always on the move. Now we're getting into the water cycle. We're learning a little bit about how water moves around our world. Puddles appear after the rain, obviously, and disappear shortly after. We saw a lot of that this weekend. This is due to the process of evaporation and condensation. The continuous alternating between these two processes makes the water cycle. So evaporation, right, which is water, liquid water turning into gaseous water or water vapor, and condensation, which is that gaseous water turning back into a liquid. The water cycle is driven by the sun's energy. This evaporation, okay, right here, this takes energy. Energy goes in. So evaporation absorbs energy in order for it to happen. And that energy is coming from the sun. So the sun ends up heating up water. The water absorbs that energy. And as a result, it can evaporate. And actually, evaporation takes a large amount of energy, a surprisingly large amount of energy. And then condensation is just when it starts cooling down enough that it turns back into liquid water. And when that happens, it actually releases energy as it condenses. All right, moving forward. So here's our picture of the water cycle. We're just going to talk really briefly about a few things here. So let's start with the plant. So plants actually take water out of the ground, which is a fantastic thing because as we talked about, a lot of water is in the ground and is not accessible to us without drilling wells and stuff. But plants actually take that water and put it back into the water cycle, back into the system. When water evaporates from leaves, this is actually a special term called transpiration. So that's just evaporation, but it's evaporation from plants. Transpiration actually is up to 97% of the water, or maybe it's 99%. I think it's 99%. We're up to 99% of the water that actually goes into the plant is just lost from the leaves through transpiration. So from evaporating from the plant. And you'll learn more about that in Science 10, but it's kind of a neat process. And as transpiration occurs, then it's going into the atmosphere. Then that water, gaseous water, at some point is going to go through condensation. Typically that happens because there's what's called sites of nucleation, which is like dust particles and stuff that's in the air, particulates that the water can collect on. And then as a result, we get clouds. Now the clouds will move around based on the wind and stuff. And by the way, the transpiration and stuff, and also the plant uptake is powered by the sun, right? That happens because of the sun's energy. Then once we have our clouds, the clouds move around because of wind, which also is due to the sun causing areas of the earth to heat up more than others. And then as a result, air moves to take up the place of the hot air that expanded and rose up. So we have clouds that end up moving around, and then we have precipitation. So then we have, our snow, our rain, our hail that ends up bringing the water back down to earth. And then from there, we end up having this precipitation going downstream, right, through rivers, into lakes, sometimes into the ocean, which means it's no longer accessible to us. But then things evaporate, or water evaporates from the ocean as well and goes back into the water cycle. Sometimes it will go into the groundwater. We have groundwater, water flow, etc. So that's a little bit of our water cycle, and it can evaporate from the bodies of water, from the oceans, wherever the water is, it can evaporate, it goes back to the water cycle, and this continues over and over and over again. So the main thing about a cycle is that it's a loop, it's a circle, it's a cycle. So it never ends. It keeps on continuing over and over and over again. And all because of this guy right here, all because of that beautiful, beautiful sun. So let's get into some notes for this that you'll have. Evaporation is when energy is used to convert liquid water from Earth's surface into water vapor. There is always some water vapor in the atmosphere. Even right now around you, there is water vapor that's in the air, and that's what humidity is. It's how much water is in the air. Condensation is when energy is released and a gas changes to a liquid. When water vapor in the air cools, it condenses and changes into liquid water, which clings to other water droplets and dust particles in the air to form clouds. Vapor in the air cools, it condenses, and changes into liquid water, which clings to other water droplets and dust particles in the air to form clouds. That actually just repeated the whole thing again. I need to change those notes. I didn't realize that. That's funny. I actually have the same sentence twice. But you get the idea. It's so important, I had to say it twice. Then moving forward, transpiration again, just that special case of evaporation. It's when water is released or evaporates from plants through the leaves of the plants. Precipitation is when liquid and solid water fall from the clouds. Precipitation may take the form of rain, hail, sleet, or snow. About 78% of Earth's precipitation falls into the oceans, meaning that right away it's mixing with that salt water and makes it unusable for us to drink. Groundwater is the precipitation that soaks into the ground when it falls. And runoff is the water that runs off the land into streams and rivers that eventually flow to the ocean if they don't evaporate before they get there. The total quantity of water on Earth never changes. It stays the same. It's just going through the cycle all the time. So water that ends up getting used up, that's fresh water, will get eventually replaced, right, from water that ends up evaporating from oceans or from other places. And it's going to keep on cycling around. But if we start using more water than it gets refreshed, we've got a big issue. Because then we don't have enough fresh water in order to survive and live and do the things that we need to do. But again, this is set in red with the stars around it because this is the most important part about the water cycle. This is all driven by the sun. The water cycle is sun powered. That's what causes the evaporation to occur. That is the absorbing energy part of the cycle. And then the rest is the coming back down of energy. As energy gets released, both gravitational energy, because it's up in the air for the water, right? And then energy as it goes from a gas to a liquid and goes through condensation, it's releasing energy as well. That's all driven by the sun. So water management. Water management involves balancing water needs of people, industries, wildlife, and the environment, with the ability of freshwater systems to remain plentiful and clean. To manage water properly, we need to know how much water we have and where it comes from. We also need to know how water is used and how it can be negatively affected by pollution and overuse. As we pollute fresh water, that means we have less fresh water available to us to use. So like I said before, it's really important that with the water cycle, we always have more water that is coming down as fresh water sources than we are using. It needs to be replenished as fast or faster than we're using it up. So this is a really neat graphic showing you where all the water is. And so I think it's neat for us to look at. So first of all, again, 97.5% of water on Earth is salt water that we cannot use. So the 2.5% of water that's actually fresh water, of that, this is more exact than what we had in previous data that we talked about, 79% of it is held in ice caps and glaciers. Now this is actually changing because of climate change. And as more and more ice melts, like for example in Greenland, this is changing and going down, which might sound good from this lesson, but trust me, it is not good. A lot of things happen, like for example, the fact that glaciers and ice caps reflect a lot of the light that comes down, right? Because they're white. So they end up reflecting the light back to the atmosphere instead of absorbing it. So as these ice caps and glaciers end up melting, more heat gets absorbed by the Earth from the sun, which means that warming intensifies, and then this process speeds up. This would be an example of a positive feedback loop, okay, which means that as something happens, it encourages more of it to happen. So 20%, so 79% ice caps and glaciers, 20% is groundwater, which leaves us 1% of that. So just to track, 2.5%, 20% of that 2.5% is groundwater. So 1% of that 2.5% is freshwater sources. 52% is water in lakes. We are very lucky in Canada that we have a huge amount of lake water. And then we have 38% is water in soil. We have some percentage that is not defined here as water vapor in atmosphere, water in living organisms, and water in rivers. So fascinating. It's fascinating stuff, but big things to come away from this lesson is number one, water is scarce, right? We need to be careful because not all the water that's on Earth is usable by us. Water is incredibly important for living things for many different reasons. As was covered in the lesson, the water cycle, knowing that that is powered by the sun, knowing the different terms like evaporation, condensation, transpiration, groundwater, runoff, and knowing just how important water is and this water cycle to us, to living. But that's it. That's it for today. Have a good rest of your day.